we will start with the Taylor series expansion problem, and the first example here is that let us say that we have f of z equals sine z, and we are expanding this function about z equals 0. Okay, so this is the question. Now we should first write the Taylor series expansion. So the Taylor series expansion is defined by f of z0. So this expansion is about z equals z0. So it is written as f of z0 plus f prime of z0 into z minus z0 upon 1 factorial plus f double prime of z0 into the brackets squared upon 2 factorial plus triple prime of the function, triple derivative, and then the cube of this bracket divided by 3 factorial and so on. So this is the definition for the Taylor series expansion here we are going to use. Okay. We are already said that we have to do Taylor series expansion, therefore we are not going to check whether the function is analytic inside this this circular region or not, this closed region or not. That we are not going to check because we are already told that do the Taylor series expansion. So we have to perform Taylor series expansion only. If you are not given which series expansion you have to perform, you are just given a function and you are asked to find the series expansion, then you will have to check first that this function is analytic in what kind of a region, whether it is in the closed region or it is in the annular region. Then you can perform the Taylor or Lorentz series expansion accordingly. Okay, here we don't have to check anything, we are already asked for the Taylor series expansion, so we will do that. This is the definition of Taylor series expansion which we are going to use. You already see here that what are the prerequisites we will need in order to use this definition, and you can already see that we need f of z, which is already given. Of course z0, but I am not considering the z0 part because we can just plug in the z0 into the function itself, so that will not be a big job. But we want the function itself, then the first derivative, second derivative, third derivative, and so on of the function, and that is the main important thing which we are lacking. So first let us find this out, and then we just have to do a multiplications only. Alright, so we already are given the function f of z, which is sine z. We will find f prime of z from this. So sine of z will become cos of z, the first derivative. Second derivative will be this, and the third derivative will be this. Once we have these functions, we can always find them at a particular point. Here the particular point is 0. Alright, so sine of 0 is 0. Then cos of 0 and this is how we can find all the rest of the functions and their derivatives. And this will go on. Okay, but at least we have found the first few terms and they are sufficient enough in order to build up the series expansion themselves. So now we can write that f of z about z equals 0 will become f of z0, which we already have here. F prime of z0 is 1 into z minus 0, because z minus z0 upon 1 factorial, plus we have f double prime, which is 0, z minus 0 whole squared upon 2 factorial, plus f triple prime, which is minus 1 into z minus 0 whole cubed upon 3 factorial, and so on. We will just simplify this, and we have something like this. So we found out the series expansion for this particular problem, the Taylor series expansion. Okay, these are the first two terms which contains the, we can have more terms also if we want, but this is how you can find the Taylor series expansion. It is so simple, right? You just have to, in order to summarize the method, what did we do? We are already given the function, find the required derivatives and find their value about which you want to expand. Plug in those functions and their derivatives into the equation, into the formula of the series expansion, and you simplify and you get the answer. So this is the definition, this is the only thing you are going to use. Plug in the values and find the Taylor series expansion. This is what you will do each and every time whenever you are giving a particular function and you are asked to find a Taylor series expansion about any point. Okay.